SIH 2024. Namaste. Our Team Helio crew came up with an ingenious solution in response for the problem statement posed by Indian Space Research Organization. The challenge focuses on building integrated photovoltaic potential assessment and visualization using LOD-1 3D city model. The strategy used for generation of electricity in India causes pollution and depletion of resources. The renewable energy sources like solar, wind, biomass and hydropower reduces the carbon emissions. Out of them, the solar energy is the cleanest and most abundant renewable energy source available, but we are unable to utilize it appropriately. To overcome this problem and fulfill the national government's aim to generate 20 to 30% of total energy from sunlight by 2030, we designed an application that calculates the BIPV and rooftop PV energy potential for a particular building according to incident solar energy for that day. The goals of our project are generation of LOD-1 3D city model, BIPV and rooftop PV calculation, shadow simulation, solar panels count. There are mainly 4 steps. The application is designed to be flexible, catering to a wide range of users including policymakers, solar energy providers, architects and citizens, enabling them to make informed decisions about solar energy potential and usage. Our interactive application allows users to input both the daily global horizontal irradiation and the specific date. These inputs are then used to calculate the precise position of the sun at any given moment. The date determines the sun's position in the sky. GHI values are integral for calculating solar potential. LOD-1 3D city model. The LOD-1 city model offers a simple yet effective visual representation of urban environments, enabling us to simulate shadows on buildings and understand how sunlight interacts with the cityscape. The visualization is essential for urban planning and energy optimization. Cartosat satellite data powers the generation of these 3D models, offering an acute depiction of solar energy falling on the city buildings on any given day. LOD-1 basic 3D block model of buildings capturing the essential urban layout, shadow simulation critical for understanding the impact of sunlight and shadows on energy capture. These are the 3 models: GeoPandas, Shapely and Plotly. To create 3D models, GeoPandas used to collect and organize map data like building shapes, Shapely to handle the shapes of the buildings and streets, making sure everything fits correctly, Plotly to show the city in 3D, allowing us to see things like sunlight and shadow. Shadow simulation mechanics. Shadow simulation is achieved through a series of calculations. Solar declination. This calculates the angle between the sun and the Earth's equator based on the day of the year. Time correction factor. Adjustments are made for the Earth's tilt and geographic location, ensuring that the solar time is accurate. Hour angle. This calculates how far the sun has moved from its peak position throughout the day. Altitude and azimuth. These metrics help determine the sun's exact position in the sky, including its height, altitude, and direction, azimuth, which are crucial for predicting shadow positions. To calculate BIPV and rooftop PV, the requirements are area, GHI value, sun exposure, and panel efficiency. Using area and GHI value, we derive incident solar energy. Using sun exposure, panel efficiency, and incident solar energy, we calculate electrical output. The BIPV efficiency or rooftop efficiency is measured from incident solar energy and electrical output. So, the number of solar panels that can be installed in a particular building to generate high potential calculated from the building area which is exposed to sunlight and the panel's dimensions. The user can select a specific building to witness the area, height, photovoltaic potential, panels count, and graphical representation of solar exposure on vernal equinox, summer solstice, autumnal equinox, winter solstice, and their average sun exposure can be visualized. The detailed report and analysis can be downloaded. Our solution leverages AI-driven chatbot to provide real-time insights, allowing users to interactively explore the solar energy potential of the buildings within a city. In conclusion, our project offers a cutting-edge solution that visualizes the solar potential, estimates panel installation, and enables users to make informed decisions about the energy optimization. Thank you.